Hello all, I am going to explain about the operation and working of Reflex Klystron oscillator, which is one of the important microwave vacuum tube device. I, Bindu AU, Assistant Professor, Department of ECE. Microwave vacuum tube devices, principle of operation of those devices is different from that of conventional electronic vacuum tube devices. How it differs is that is microwave frequencies, as we all know, ranges from 1 gigahertz to 300 gigahertz. When conventional electronic devices are used to produce frequencies beyond 1 gigahertz, their operation will differ because of the three main parameters that are inter-electrode capacitance, lead inductance and electron transit time. So these three parameters will widely change when the frequency goes beyond 1 gigahertz. So specialized vacuum tube devices are required to produce microwave frequencies. So such devices are called as microwave vacuum tube devices. Under that, there are so many microwave vacuum tube devices like Klystrons, magnetrons. So in that, one of the low power efficient microwave device is Reflex Klystron. Klystron oscillator is available in two configurations. One is Reflex Klystron which is used for low power microwave oscillations productions. And another configuration that is available is multi-cavity Klystron, which is used as low power microwave amplifier. This is used for amplification of the produced microwave oscillations. So in this video, we will be understanding the operation and how microwave oscillations are produced using Reflex Klystron oscillator. This is the functional diagram of the Reflex Klystron oscillator. There are other variants of this available. This is the one simplest one which we can easily understand the operation of this Reflex Klystron oscillator. It basically consists of an electron gun which is used to emit the electrons, and that is supported by a focusing electrode which is used to focus the electrons that are emitted by this electron gun, and that is connected to a negative voltage. So thus it acts like a cathode, and it consists of a vacuum tube. So this is a vacuum tube part of it, and this vacuum tube is inserted with a resonant cavity, reentrant resonant cavity, and that cavity is connected with a positive voltage. Thus it acts like a anode, and across the another cavity the microwave oscillations that will be produced will be taken out either with the help of coaxial cable or waveguide. So here, by inserting this cavity into the vacuum tube, it creates a gap inside the vacuum tube, and that gap is indicated here. Across that gap itself, the microwave oscillations will be produced. So there is one more that is present here, that is a repeller which is connected to the negative voltage, and it acts like a repeller electrode. Anode is provided with the positive voltage and repeller is provided with the negative voltage at both of its ends. So now let us understand how this reflex klystron oscillator will work. To understand the principle of operation of this reflex klystron, we need to understand the principle of operation of microwave vacuum tube devices. Microwave vacuum tube devices operate on the principle of electron velocity modulation. Electron velocity modulation is the main principle on which the microwave tubes operate. So what is this electron velocity modulation is? The speed of the electrons will vary with respect to electric field. So that is why it is called as electron velocity modulation. So as we say, the speed of the electrons will vary. What does that mean? It means that either the electron speed will increase or decrease. So hence the electrons are said to be either accelerated or decelerated. So how it happens is that is, so if we consider an electrode, electrodes will be, one of the electrode will be positively charged and another electrode will be negatively charged. So the electric field direction will be like this. So the electrons whichever moving in the opposite direction of this electric field, the electrons which are moving in the opposite direction of the electric field will increase in speed. The velocity of that will increase. How it increases in speed is by absorbing the energy. The speed of those electrons will increase and thus these electrons are said to be accelerated. So they absorb energy and the velocity of it increases and thus they are said to be accelerated. If the electrons are moving in the same direction of the electric field, say if we consider the electrons which are moving in the same direction of the electric field, if they are moving in the same direction of the electric field, they lose their energy and thus their speed will reduce and thus they are said to be decelerated. So these electrons are said to be decelerated. So that is how with the electric field, the electrons will get accelerated or decelerated. So this is the principle of operation of any vacuum tube devices. With this understanding, so now let us understand how the microwave oscillations will be produced in the reflex klystron oscillator. Here, the DC voltage is applied to the resonant cavity. So this DC voltage will be converted into a RF noise, radio frequency noise across the gap. So that will be producing a noise at the RF frequency. So this resonant cavity, since it is a resonant cavity, it will be producing a resonant frequency. So that RF noise with the resonant frequency, that resonant frequency will increase with the frequency that is produced by the resonant cavity. So that frequency is present at the gap. The electrons which are emitted by the electron gun will interact with this RF noise that is present at the gap. So when they interact with the RF noise that is present at the gap, it will undergo electron velocity modulation. By that action, the microwave oscillations, frequencies at microwave frequency range will be produced by this. How is that can be understood? With the help of this diagram. This diagram is called as a applicate diagram, which will be representing the function of or the mechanism of oscillation of reflex klystron. Here we have represented the RF noise that is present across the gap. The RF noise is nothing but the cavity gap voltage. So this is the RF noise voltage. So the electrons which are interfaced with that RF noise will be undergoing electron velocity modulation. So that is what is represented in this waveform. So this is the distance from the cavity gap. So that distance from the cavity gap is the distance from the cavity gap, this is the gap, to Rippler electrode is the distance. That distance is considered. Why is that? We will be knowing soon. Now what happens is the electrons whichever encounter the positive RF voltage will get accelerated, like electron velocity modulation. So field is positive, so the electrons will get accelerated. So as they get accelerated, they move with a faster speed. And the electrons, let us consider that point as A. So let us consider a peak positive point. So whichever the electron which is moving at peak positive point or all of the positive voltages, all of those electrons will get accelerated. Let us consider a reference point B. This reference point B is at 0 voltage. Since the voltage is 0, the electrons will not undergo any velocity modulation. Either it will not be accelerated or decelerated, it will move in the same speed. It moves in the same speed, and the electrons whichever are encountering the negative half cycle, that is the negative voltage, will get decelerated. So with the principle of electron velocity modulation, and thus it moves with a lower speed. So now what happens? Some of the electrons are moving with a higher speed, some of the electrons are moving with a lower speed, some of the electrons are moving with the same speed. So now what happens in the reflex klystron oscillator is so in this gap they are undergoing electron velocity modulation, and after that they tend to move in the vacuum tube and try to reach this Rippler electrode. When they try to reach that Rippler electrode, that electrode is provided with a negative voltage, so all of the electrons will get repelled from that electrode, and hence it is named as Rippler electrode. So all of the electrons will come back to the gap once again for the second time. So when they come back to the gap for the second time, it can be adjusted such that the electrons which ripple back to the gap second time to coincide with the next positive peak voltage by adjusting the Rippler space. Rippler space is nothing but the space between the gap and the Rippler electrode. So by adjusting that space, it can be done that these repelled electrons can coincide with the positive peak as shown in the diagram. So thus it coincides in the next positive peak, all of those electrons will coincide and they form bunches. This is bunch of electrons. They form bunch of electrons. So these bunch of electrons will lose their kinetic energy. Okay, so when they coincide with the positive peak, so they lose their kinetic energy, and that energy will be absorbed by the cavity, and thus the amplification of the RF noise will happen. So as more and more electrons coincide, the bunch of electrons coincide with the positive peak, so the RF noise gets amplified. So as the RF noise gets amplified, so microwave oscillations will be produced, and that microwave oscillations will be taken from the cavity using a coaxial cable as shown here. The RF output or microwave output will be taken across that. So when there is a balance between the power loss and the power absorbed, the kinetic energy lost by the electrons will be absorbed by the RF noise. When they are getting accelerated, so they will be absorbing the energy, and when they are getting decelerated, they will be releasing the energy. So when there is a balance between the loss and acquired energy, steady state oscillations will be produced, and that oscillations will be in the frequency of microwave, and thus the microwave oscillations are produced. So this is the working of the reflex klystron oscillator. Thank you.